Before going through the example of how to use this Plutus simple model library, first let's see how we can open the documentation. I added this handy command, serve testing docs, and if you run this, it will open the Plutus simple model documentation in your browser. As you can see, you can scroll to learn more about the library. Make sure to be using version 5 or later of the Docker image. If you're in doubt, just run rebuild container and you're ready to go. So now that we have the docs ready to go, let's open a new terminal and go over the code. We start with the main action. This is the entry point of our code. When we run Caval test and the name of the test, this is the action that runs. Now here we have a bit of boilerplate. We have this default main function provided by Tasty that transform a tree of tests into the IO action that main needs to run. And then we have this handy function test group that allows us to give a name to a list of tests. This is really handy, especially when you have maybe dozens of tests and you want to classify them in some way. And finally, we have the list with the actual tests, each with its own message or description and the actual test. So we have a test group with the test simple user transaction description, and then two different tests, one with the simple spend description and one with the not enough funds. In the simple spend test, we make user 1 send a transaction to user 2, and everything should be okay. But in the not enough funds test, we also make user 1 send a transaction to user 2, but this time we send more value than we actually have. So it should fail. So when we go to the week 6 code and run Cabal test week 6 PSM, the name of the file, we run this main action that first has to compile. Wait for a bit. And there you go. As you can see, the same descriptions we provided here are provided right here with the result and time needed to complete the test. And as you can see, all 2 tests passed. Perfect. Now let's see how we accomplish this. So we have this simple spend and not enough funds functions that both return a value of type run boolean. So we know that we have to run the state monad to get the boolean as a result in both cases. And these 2 functions are the second parameter of the good and bad functions that we defined over here. The good function is actually a partially applied test no errors function that takes a couple of parameters. First, the value we provide to the admin user. Same as the previous video, we had a single UTXO at the very beginning with a list that contains 1,000 coins. In this case, we provide 10 million coins to the add a value function. As you can see, it takes an integer and returns a value. And we also provide the default Babash mock config. This is the configuration of our mock blockchain. So these are the 2 values that we provide to initialize the state of the blockchain. But test no error needs other 2 parameters, the string and the run action, that are the 2 parameters we passed right here. So at the end, we get the test tree that we need. In the case of the bad function, we have this must fail function that logs an error if everything goes well. So it flips the script around. In the case of test no error, it will log errors if there are actual errors. But in this must fail, it will log an error if everything succeeds. But if there is an error, it will succeed. In the first test, we anticipate that this test will succeed. And in the second test, we anticipate that the test will fail. And if it fails, it's good, because the user tried to send a transaction without enough funds. That's it about the main action. Now let's see the actual simple spend and not enough funds tests. First, we have to create a single helper function called setup users. In this case, we need a couple of users to start testing. So we use this new user function that takes a value and creates a new user by transferring that value from the admin user that has, in this case, 10 million coins to the new user. And the value that passes is 1,000 Loveless. We replicate this behavior 3 times. So at the end of the day, we have a list of 3 PubKey hashes for the 3 new users with 1,000 Loveless that we created. Now that we have this helper function, let's use it. Let's see the simple spend action. Simple spend, as we saw before, is of type run boolean. So we know that it does actions in the state of the blockchain, and at the end of the day, it returns a boolean. Let's see the actions. We start by creating the 3 users we just prepared in the setup users. Now, because this setup user is of type run list of PubKey hashes, and we actually need this actual list of PubKey hashes, we are going to bind the result of running this action into the users variable. Now that we have our PubKey hashes, we can give names to the individual users. This is not strictly necessary, but it's convenient to have the user 1, user 2, and user 3 already named. And then we do the actual transactions. We create the first transaction. We use the send value transaction that takes the PubKey hash of the person that has to send the ADA, the value that has to be sent, and the person that receives the ADA. And at the end, it doesn't return anything useful. In our previous example, in our own mock chain, we returned a Boolean saying if the transaction succeeded or not. In this case, the success of the transactions is logged as a part of the state of the blockchain, so we don't have to even take care of that. So we first send 100 Loveless from user 1 to user 2. Then we do the same from user 2 to user 3, which means that because all 3 users start with 100 Lovelesses, user 1 should end up with 900, user 2 with the same as the very beginning because it gained 100 and lose 100, and user 3 should have the extra 100 that are missing from the 2 previous ones. That assuming everything went well. And how can we check if everything went well? Using the no errors action. No errors checks if all the previous transactions, remember that in each line, except for the let bindings, in each line we change the state of the blockchain. So by when we get to this line, we already made the transactions to create the 3 users and the 2 transactions to send value. So if we run the no errors and it returns that everything is okay, a Boolean, it means that all the transactions went well. But not only we want to check that all the transactions succeeded, but also that the final balances are the ones that we are anticipating. So for that, we read all the values from the users. We have this value add function that takes a PubKey hash and returns the value in that address. And because it only takes a single PubKey hash and returns a single value, we map this function through the list of our users to get a list of values. Then we check that both everything is okay, so all the transactions went well, and that the actual values that we get after making all these transactions are equal to the expected values that are 900, 1000, and 1100. If both of these are okay, it's true and true returns true, but because we have to return run of Boolean, not just a Boolean, we wrap this true using the return function. And that's how we get the simple spend test. Then to check if a transactions with not enough found succeeds, we create this simple function that's actually pretty short compared to the previous one. We set up our users, we name them as previously, but now the only thing we need to do is to create a transaction with too many Lovelaces. In this case, we create one that user 1 that has only 1,000 Loveless wants to transfer 10,000 Loveless to user 2, and this will of course fail. So if we run the no errors action, we should get false because there are errors. This should fail. We don't need to do the is okay, return is okay, because the last action in a do block is actually the one returned as the final value of the do block. So actually the LSP is letting us know that redundant return. So as I said before, this is not necessary. And that's it. As you can see, it's not super difficult. It's pretty simple if you understand how the state monad works. And it's not much code, so it should be pretty easy to reproduce this with your own tests. In the next lesson, we're going to test an actual smart contract.